Okay, let's get right into it. We live so much of our lives online, right? Banking, travel, work. We just expect it to be there, to just work. But as we've all seen lately, our digital world is way more fragile than we think. We're going to talk about why everything seems to be breaking all the time and explore this new, fascinating science of building systems that aren't designed for perfection, but for survival.
I mean, it's the question we've all asked ourselves, probably while staring at that spinning loading icon on an app you desperately need. And no, you are not imagining it. From huge cloud outages to botched software updates, the very foundations of our digital lives are showing some serious cracks. But why? What's really going on here?
Well, for the better part of a decade, the big goal in tech was all about one thing: maximum efficiency. Make it faster, make it cheaper, centralize everything. The problem is that created a system that was incredibly brittle. So now there's this fundamental shift happening. The new goal isn't just about speed anymore. It's about what's called active resilience. It's a whole new way of thinking that's focused on one thing: how to survive when things inevitably go wrong.
So here's how we're going to break it down today. We're going to look at 4 of the biggest threats out there: what happens when the cloud itself falls, the dreaded update of death, the very real danger of cutting the internet's physical veins, and how to survive a digital flood. Then we'll pull it all together into a new set of rules for digital survival.
All right, let's start with the big one, the cloud. We moved everything there because it's powerful, it's convenient. But in the process, we basically put all of our digital eggs into just a few very large baskets. So what happens when one of those baskets gets dropped?
And this is not a what-if scenario. Back in October of 2025, Amazon's massive US-East-1 cloud region just went down. For 14 agonizing hours, millions of people were cut off from countless websites, banking apps, you name it. It was like a digital heart attack, and it exposed a huge flaw in how we've built the modern internet.
You know the craziest part? The cause wasn't some massive cyber attack. It was a tiny, subtle software bug called a race condition. You can think of it like this. An old, outdated command was supposed to be replaced by a new one, but it arrived a split second late and overwrote the correct one. That tiny, microscopic timing error created a domino effect that brought the entire system crashing down.
And that explains why it took so incredibly long to fix. The engineers who were scrambling to repair the system realized that their own tools were also hosted on the broken system. The very things they needed to fix the problem were caught in the outage. It's a paralyzing loop. It's like locking your keys in your car and then realizing the spare key is also locked in the car with them. You're just stuck.
So what's the fix? Well, you can't put all your trust in one single provider anymore. The modern solution is to go multi-cloud, using several providers like Amazon and Microsoft at the same time. As you can see, sticking with a single cloud is simple, but it's super high risk. Going multi-cloud makes you way more resilient, but, and it's a big but, it's also way more complex and a lot more expensive. There's no free lunch here.
Okay, on to our second major threat. And this one is a true paradox. It's when a software update, the very thing that's supposed to help and protect you, ends up causing a global shutdown.
In July of 2024, this number became a nightmare for IT departments everywhere. A single, faulty security update from a company called CrowdStrike bricked 8.5 million Windows PCs around the globe. We're talking airlines grounded, banks shut down, hospitals in chaos, all from one bad line of code?
And the reason this was so catastrophic is because this wasn't just some little app update. It was a security tool that operated at the kernel level. That's like the absolute core, the very heart of the Windows operating system. So when the bug hit, it didn't just crash a program, it crashed the entire machine, triggering that infamous blue screen of death on a global scale.
And so how do you stop that from ever happening again? The defense is actually pretty brilliant, and it's called a canary deployment. You know, like the canary in the coal mine? Instead of pushing an update to millions of people at once, you do it in small, controlled steps. First, just your own employees. If that goes well, you roll it out to maybe 1% of your real users. You watch the data like a hawk, and the second you see error rates go up, the system automatically yanks the update back. The potential damage, the blast radius, is kept tiny.
Okay, let's switch gears from the digital world to the physical one. It's easy to forget that the internet isn't some magical cloud. It's a very real, very tangible thing made of wires and cables, and those cables can be cut.
Just let this statistic sink in for a second. We think of our connection as wireless, happening through the air.
But the reality is that nearly all international data, the entire lifeblood of the global economy, flows through a few hundred massive cables lying on the bottom of the ocean. These are the veins of the internet, and they are shockingly easy to damage.
And this is happening right now. In 2024, a few cables were cut in the Red Sea, and bam, 25% of the data traffic between Asia and Europe was just gone. Other incidents in the Baltic Sea have shown just how easy it is to disrupt an entire region, sometimes with nothing more than a misplaced ship's anchor.
The new survival strategy, then, has to be about physical diversity. You can't just have all your connections running along the ocean floor. True resilience means having completely separate backup routes, like the new networks of low Earth orbit satellites. It also means building what you could call autonomous lifeboats, local data centers that can keep critical services running even if their main connection to the internet is completely severed.
Our fourth and final threat is the good old DDoS attack, distributed denial of service. But forget what you think you know. These aren't just simple floods of junk traffic anymore. They've evolved into intelligent, overwhelming digital tsunamis.
In May of 2025, network providers had to fight off the largest DDoS attack ever seen. It clocked in at 7.3 terabits per second. Now that number is so big, it's basically meaningless, right? So let's try to put that into perspective.
Okay, look at this. That tiny little sliver on the left, that's your home internet connection. The next bar over, that's a pretty big corporate connection. And that colossal tower on the right, that's the 7.3 terabit attack. You can't just buy a bigger firewall to stop that. That's like trying to stop a tidal wave with a beach towel. It's just a different scale of problem. The solution here is actually incredibly clever. It's a technique called anycast routing. So instead of having just one front door for all your traffic to come through, you create hundreds of identical front doors all over the world. The attack traffic naturally gets spread out among all those doors. So instead of one poor data center getting slammed with an impossible 7.3 terabits, you have 477 locations, each dealing with a small, totally manageable piece of the attack. You just diffuse the flood.
So, after looking at all these massive threats, cloud failures, bad updates, cut cables, and digital tsunamis, what's the big lesson here? Well, it's pretty clear the old rules of just being fast and cheap are over. A new philosophy, one built for survival, is taking over.
And this is really the core idea. The new goal is something called gradual degradation. It's this acceptance that things will fail. It's inevitable. So the objective isn't to build a system that's unbreakable, but to build a system that can break gracefully, to contain the damage so that one failure doesn't cause the whole thing to collapse.
So let's boil it down. Here are the new rules for survival. Use those canary deployments to shrink the blast radius of bad software. Make sure your systems aren't totally dependent on a single cloud provider's control systems. Diversify your physical routes, sea, land, and space. And finally, you have to use AI to fight back against these new, smarter, AI-powered attacks. These are the new pillars of a system built not for perfection, but for survival.
And that really leaves us with one final big question to think about. Maybe, just maybe, we've been chasing the wrong goal all along. Maybe the future of a truly reliable internet isn't about achieving some flawless, unbreakable perfection, but instead about mastering the art of building systems that are designed from day one to know how to break gracefully.